I'm John Kjell at ControlPlane. Just started on Monday, so I know mostly about what the company does through the interview process. But we have a booth here, too. I'm also a co-chair for the CNCF security tag and a maintainer on Witness and Archivista, which are sub-projects underneath in-toto. And I've contributed to things like the Salsa project and other things.
Yeah, my name is Kairo. I'm an open source software engineer as well. I'm a maintainer of TUF, Python TUF library, and also Archivista, an in-toto project as well. And we are here to talk about identity-based trust.
All right, so just to prepare you all, we're going to talk about the in-toto project, the TUF projects, implementations underneath each of those, and the Sigstore project and its different components. This is a lot. I apologize in advance. Hopefully, your brains don't melt. Preparing this, ours did slightly. So the other thing that this does not include is introduction to the cryptography or X509 certificates or the underlying technologies that have made all of these different projects possible. So we will be, well, I will be available for as long as needed afterwards for follow-on conversations. We also have each of these projects in the project pavilion, so feel free to stop by there as well, too. in-toto and the update framework have both had people write entire PhDs on them, so we will try to do them just as we can in the amount of time we have.
OK, let's start about signing and how we used to do in old days. Actually, we're still doing that. So how it works in general. Basically, you have a private and public key that it's from some person or some organization. And based on that, you use your private key to sign some artifact. And of course, you keep your private key saved. And it generates for you a signature. And as your private key is saved, you share your public key, basically. And other people can just get the private key, the public key, and a signature, and validate the artifact signature. So, but what's the problem and how you share new trusted keys? If you lost your private key or this private key got leaked. So the solution is quite easy. You generate a new key, you resign the package with the new key, and you publish your public key, new public key. And you need to tell in a trusted way to your users to use the new public key, right? And after resign everything, you need to take in mind the amount of artifacts that you need to resign everything, and wait for the replication in CDNs, mirrors, and caches all there. OK, how we do nowadays, based in OIDC, identity signature, basically, you want to sign your package on artifact. You can use cosign, for example. And Sigstore cosign will generate a verification of your identity. And with this verification, generate a temporary private key that will sign the artifact. And it will generate a certificate. And the private key is destroyed. You don't need this key anymore. It's what we call ephemeral keys. So with that, users and client can just use the certificate to validate your signature in the package. But this was the top level, high level, how it works. But behind of this, I'll let John tell about that.
Yeah, so you can see to the left side here, developers, they have a thing they would like to sign, requesting a certificate, which gets authenticated with OIDC. That certificate request goes to Fulcio, which is one of the projects we mentioned, that provides the signing certificate and also publishes that certificate in the Rekor transparency log. Then when the developer publishes the artifact that is signed, you're able to download it as an end user on the far other side here. And then the end user will go through the verification process of checking that signature in the transparency log, and also checking that the signing party of the certificate is actually a part of the trust root. So there's the update framework embedded underneath of Rekor and Fulcio. And so once this happens, that signature is in Rekor forever. It's trusted forever. It will always verify. And so what are we going to do about that? We're going to walk through kind of an example project we have here. Just in time for KubeCon, we were not in a rush at all. We released v1.0 of our software. So we tagged it. We pushed it. It went through our GitHub Actions pipeline. We got success. And there's a Docker image now. So people can go and start pulling this Docker image. Everything will be wonderful. Now, one thing we wanted to do things the right way in this software project was to create Salsa build attestations. And so we use Witness to wrap the build process and create a Salsa build provenance, which you can see a link to here in the summary from the GitHub Actions. Now, Salsa, if we look at this overall set of things that can happen throughout your supply chain, is really focused on these things in the middle here. And that's good, but you can see there's a lot of other triangles not on this screen. And in addition to that, there's a whole bunch of things that are not even on that threat model, right? Things that should be happening, hopefully, that might not be, or you have no way to trust or verify that those things have happened. So things like your vulnerability scans, static analysis, code reviews, testing. I can think of at least one situation in which vendors writing things like kernel modules or device drivers on Windows should do more testing before releasing software. It might be good to ask them for an attestation proving they did testing, or license compliance. A lot of these things. In our pipeline here, this is kind of the end-to-end for the release we have. You can see we're taking a lot of these different steps. For every one of these steps, we're creating an attestation. All right, so since we were in a little bit of a rush for KubeCon, we had a bug in our software. We need to fix it. So we've got an emergency release here. We just smashed merge on that PR. We're going to tag everything in the repository, push that to the GitHub repo so that we can kick off our release process. Our customers are absolutely clamoring for everything. We need to get this out the door as fast as possible. So we're going to speed through. We've got our super mega GitHub Actions builders running underneath here to accelerate the process. And you can see we're going to go through. And once again, we're creating attestations for every step along the line here. Every one of these attestations are signed with a certificate from Fulcio, so we can verify them. And we're going to go through our release process. You can see everything here is green. So we're good, right? Well, we're going to check. We have a policy from the Witness project. And this Witness project makes sure that the policy wants to make sure. We'll go right back to that there. Whoa. All right. It's going to make sure that our expectations about each one of these steps matches reality. And so in this case, we can see an error message about our linting step. We have a Docker file linter in our pipeline looking for things that we don't want to have happen in our Docker file. And so somehow in between the previous release and this one, something changed. But the thing is, the attestations were all valid still. The signatures all passed. Everything in the pipeline was green. All right, so here was the code that was removed from the PR. That's right, we needed to take the panic out of there for some reason in order to have working code. But there were some other things in here, I don't know, AI generated probably. Someone decided they needed the container to be root, and they just so happened to know the right rule to ignore from the static analysis tool so that that wouldn't fail in the pipeline. And the policy was able to detect that. So, but what happens if there's some sort of compromise to the signature process that you can't detect, right? So if you look at things like this whole giant set of components that back that workflow we looked at for the identity-based signing before, if there's a compromise to your OIDC provider, someone could be able to take that identity and request any number of certificates from Fulcio. The way that you would try and mitigate something like that would be by examining the certificate transparency log that's behind Fulcio. If there are a compromise that way as well, you can have a Rekor monitor observing the entries in the log, looking to see if things are unexpectedly published under your name. If Rekor itself, it's an append-only transparency log. If someone tries to modify that in some way, the hashing and the indexing of the entire log will be disrupted. It's externally something that can be externally validated. Anyone can look at the log and do that sort of computation. So there's a lot of different ways to handle this, but the thing is, all it handles is detecting that there was an issue. Rekor, as I said, it's an append-only log. You can't remove any of those entries. So what we really need here, and what we kind of saw with the attestations, is you need that extra layer. And so by actually looking and signing something that has contents in it that can be inspected, you can make better decisions about trust. Or the other thing that's not going to show up in any attestation or signature process or anything else, you've released bad software. All right, so let's go ahead and try and fix this issue the right way. So we're going to go ahead and look at the PR this time before just smashing merge. We're going to see that we're removing the ignore and also removing the root from the container image. Now we're going to go ahead and go through the same process to kick off a new release. So we'll tag this and push this up. The GitHub Actions workflow will kick off again. And as this runs, we are creating these attestations. All of these attestations are also being stored in Archivista. And so that's when we're able to do the policy evaluation, it indexes and understands the relationship between all of these attestations. So it's capturing the inputs and the outputs and understanding which sets of attestations to use when we do this verification process. So here we're going to see this kick off once again. And hopefully it's going to make sure that that linting step passes. And in this case, it does, which is good. So now we've got everything meeting our policy expectations. Now we'll see how we actually distribute this securely.
Yeah, what we saw here, we did actually 3 releases, and all of them are available in our registry. But how we avoid the users to deploy those versions that are with the malicious part. So what we want to do now is secure the last part here, the distribution of those images. And the way that we do here is using the update framework, tough. So what we do here, let's go for the next demo part. Yeah, so we have everything verified. Signatures are OK as well. So what we can do now is using tough to approve the metadata that has all the artifacts that you want to distribute. And we see that 1.1 is here, and we want to remove it. So what we're going to do first is remove this. to make sure that our deployments will not be able to fetch this version. Once it's removed, it still requires someone to sign. Here we are also using those identity signatures. Here you see John using the Sigstore to sign the metadata as well. Then what you're going to see now that the users will be able to download safely the version 1.2, verifying the tough metadata, verify that John approved it by the signature. And tough helps that you can rotate those signatures as well. So, well, now what we want to do is remove 1.0 as well. We can avoid the user to use the old version that is compromised with the bug. Then we sign it, the new metadata. We can see that we have now just 1.2. And now if you try to download the buggy version, you're not able to do that. So I cannot tell too much about tough in that talk, but who want to listen more, I will be running to my next talk right after this one that will be about tough. But I can explain the important part here. That was the client that we use, how tough client works in a big picture. You have the tough client, and we store your artifacts in anywhere. In our case here, we are using a GitHub container registry, but could be the Docker Hub or Harbor, or even your JFrog in your organization. And you have the tough metadata that's usually stored outside of the same storage, but you can leave it together. There's no problem about security on that aspect. So all the tough client contains the initial root metadata that contains what are the keys that can sign my metadata, and what are the signatures already there. So it is usually embedded in the tough client. You distribute that. The advantage, you can never need to go to your client and say which keys they should trust or no longer trust. The metadata can validate that. How it's done. Here an example following our demo. Let's say that you want to download the version 1.2 that we released. What happens is the tough client will check for the new versions of the tough metadata. And this check is done by the client, and the root metadata can validate the next one. It can see if the signatures are good or not. Even the rotation of keys, you see that it can verify if the rotation of keys was done in a safe way or not, and what are the current signatures. After there is no new metadata for the root that contain the keys, it will download other metadata that I will not go in details here, but basically it's the timestamp that will guarantee that your artifact storage, where is your registry, it's updated, and also the consistency of your repository. And the next step, actually the last step, is to verify your container if it's the container that you are expecting. Basically, it will download the artifact, and after the validations of signatures, it download the artifact and can check, for example, the hash and the size of your image, what is signed in the metadata. So it will, if it passes, you get that, okay, you can go and deploy this image safely. And what happens when you are not assigning, like we deleted, for example, the version 1.1, right? But in the registry, it's still there, it's still available. Or imagine that you have CDN caches or distributed. This image is still there. How tough will secure you? The thing is that in the metadata, this version is not signed, so it will not allow you to download it, so it's not a safe one. Yeah.
Yeah, so kind of going back to the beginning of everything and these identity-based signatures, the idea of just, say, signing your container image is not enough, right? We looked at different ways in which we can add additional layers on top of that to understand whether or not you really should trust that signature or really that artifact, because the only thing this signature is doing is saying, this is a thing that I signed. It's not saying much else besides that, right? We get a little bit closer with things like salsa build provenance, where you can say, this is a thing that I've signed that came from this location. So if you have a package that's in the NPM registry or PyPI or something like that, that's disconnected from the GitHub repository. How did it get from the GitHub repository to there? The salsa build provenance can prove that. But things like whether or not the code is safe, secure, that's not necessarily answered. We added a bunch of steps in to our pipeline to address some of those concerns by doing things like linting. And in order to have that chain, that set of attestations, and verify them all together, we have to have a policy. And so that was the witness policy, able to detect someone modified the linting step, and we knew that that shouldn't verify the policy. That software was released in this case, but it was never actually distributed through the secure release process. And then once we had everything secured, being able to then release it the right way with the update framework, that's a really good way for organizations to decide on their own what software is safe to consume. So,
yeah. That's it, yeah.
Yeah, so I know that was a lot. We have time for questions if any of that was comprehensible and there's any particular part of it folks want to dive into a bit more.
Hi. Can this be run fully offline? Or which part needs an online connectivity?
Yeah, you can run all of this offline. There's a lot to deploy offline, I suppose. So from what we've showed, storing the attestations in Archivista, you can run that locally and store that there. The Sigstore instance to run offline is a little bit harder. One of the things that Sigstore is moving towards is the bundle format that can be stored offline, and it has things like an inclusion proof rather than having to look up the entry in the transparency log, as well as a signed timestamp. And so that allows you to ensure the certificate was valid at the point in time the artifact was signed. That way you can do that validation without having to call to the transparency log. And then Tough is often deployed in air-gapped environments. And in fact, the update framework has a variant of it called Optane, which is what powers a very large majority of all of the automobile updates over the air. So you can imagine a car parked in a garage for months at a time, not turned on, still needs to figure out how to get updates after it comes back online.
Yeah. No, yeah, and Tough, you can also bring the metadata to validate offline as one. If you have the initial metadata in the place already, you can bring the whole metadata offline. And you have ways to deploy, to remove like the timestamp and snapshot, or not remove them fully, but trust them in a more offline way, like not with often updates. Yeah.
Okay, thank you.
Hi, thank you for the talk. Can you give a bit more detail on the first example when you run the witness verify? What exactly happened there? Why did it fail?
Yeah. So let's see here. We'll do a little lot. We'll see if the internet is working. So all of this is in a GitHub project that's public. You can see the runs there, even though we have recorded video. There is a policy file in here, and inside of this, it lays out all the different steps that we expect to have happen. And one of the steps is this linting step. And inside of the linting step, there's different groupings of the attestations. And this is called the command run attestation. And so it captures the parameters that are used, the inputs, the outputs to standard out, standard error. It captures all of that, and then you can write a rego policy against that. So this rego policy here, I'm not sure if there's basically what it is looking for in that rego policy is that the command executed matches the expectations, which doesn't allow for any -- ignore flags.
So you did run the linting, but because there were ignore flags, this failed the verification later, right?
Correct, yeah.
Thanks.
Yeah, and so if you would have the root properties in the Docker file, the linter would fail. And if the linter would fail, then the pipeline would fail, and the developers would see something is wrong with this. It never would have built the container image.
But in that case, why not just fail the CI?
So this was maybe a way to avoid getting the CI to fail. So since the code review wasn't sufficient to know that this would be essentially a workaround. And so you're able to decouple the policies you create from the pipelines. And you may not even have control over that. If you want to write policies just as a consumer of this, you may have different expectations or standards about what you want to have happen. So it's a good way. Or if you want to have these sort of policies as an organization for software developed internally, you don't want to stop your developer pipelines, right? You don't want to be a roadblock for them being able to do their work day to day. And so having that policy happen later on is a good idea sometimes.
Yeah, and it was a way also to demonstrate that if you didn't write a good policy in your pipeline, it could anyway release. So you need to have a way to secure you after that anyway.
Got like 2 more minutes if anybody has any other questions.
Hi. So the last point that you're verifying and the thing that kind of says it all, yes or no, I trust it or not, is that last registry signing? Once the image or the binary is in the registry, that's when I think use Sigstore still identity, essentially.
So at the very end, when we were doing the secure download, that was with a tough client. So that the information about whether or not we could download something was stored in the tough metadata. And so the client is able to query against that and understand if it should pull the image from the registry.
Yeah. And the signatures there actually are to prevent that someone could modify this metadata to allow you to download it, but without the signatures from Sigstore, for example, it would not permit it.